Hello, we're going to go ahead and start going over rational graphs. So let's take a look at number 1 over here and figure out what we're going to do to get started. The rules are up here on the top of your paper, and these are the things we're going to have to find before you can even begin to graph it. We need to know what the vertical asymptote is. We need to know if there's a horizontal asymptote or a slant asymptote. We also need to figure out if there are any holes, and the last thing, where are the intercepts located? So let's go ahead and start with the very first one, that is vertical asymptotes. That's, oh wait, well before we do any of that, what we need to do is take a look at number 1 and see if there's any way that we could go ahead and break that down. The top portion here can be factored, right? So two numbers that multiply to give me negative 12, but add together to give me negative 1. It breaks down into x minus 4, x plus 3. Okay, just like that. And the bottom portion is still x minus 3. Is there anything that we can go ahead and cancel? No. So then, since we can't do that, and that's as simplified as it will get, we could go ahead and start answering these questions here. What about that vertical asymptote? That's when you take the denominator, x minus 3. Let's see if I can run out of room here. And since it's x minus 3, that means your vertical asymptote is going to be x equals positive 3, because you take x minus 3, set that equal to 0, and you get that x equals positive 3. All right, so the next thing we need to do is figure out, do we have a horizontal or slant asymptote? If you can find the definitions up here on the top, but if there is a slant asymptote, that means this right here, otherwise known as n, okay, n is 2, m is the exponent down here on the bottom, or the degree, right? So the degree on the top is 2, the degree on the bottom is 1. If the top part, or n, is exactly 1 more than m, which it is because it's 2 over 1, that means we have a slant asymptote. And y'all, remember that you're not going to have a slant asymptote and a horizontal asymptote at the same time. So how do you figure out the slant asymptote? We have to do synthetic division. So let's go ahead. I'm going to do some synthetic division down here where I've got some space. Okay, so we got x minus 3 on the bottom, which means we're going to have a positive 3. Then we take the coefficients, 1, negative 1, and negative 12 from the top. Okay, bring down the first number, multiply, add going down, multiply, add going down. Now, we don't really have to do the last part, right? We don't need to know the remainder. All we need to know is the 1 and the 2 part. And this means that the equation is 1x, or just x, plus 2. So for slant asymptote, I'm going to write y equals x plus 2. All right, there's no holes, and the reason why I know that is because we didn't have to simplify this particular problem. When we do, we will have holes, but since you did not have to simplify, there are no holes there. So the next thing we need to do is figure out the intercepts. Okay, y-intercept will be located at wherever, okay, so let's go back over here. I'm going to plug in, I'm not going to use the simplified version. I prefer to use this version over here, okay, where it's standard. So for y-intercept, you have to plug 0 in for all the x's and then see what you've got. So you've got 0 squared minus 0 minus 12 on the top, so it's a negative 12 over negative 3. And negative 12 divided by negative 3 is positive 4. So my y-intercept's located at 0, 4. For x-intercept, this is where I'm going to want to use the factored version. Okay, we're going to take whatever is in our numerator and set that equal to 0. So check it out. I've got x minus 4, right? So what does x need to be here to make that 0? Is 4. So 4, 0 is going to be one of my x-intercepts. Over here, what does x need to be to make this little portion equal to 0? It's negative 3. Right, so I'm going to put down negative 3, comma 0. So that's everything I need to go ahead and graph. So I'm going to have an asymptote. Let's start with the vertical asymptote. X equals positive 3. Now, I'm going to do this in a different color. So go to where x is 3 and draw a dashed line. Then we're going to graph the slant asymptote. Now the slant asymptote is a little bit different, right? We've got 2 for the y-intercept. So go ahead and put that point there. And the slope is 1, or 1 over 1. So rise 1, run 1. And then we can connect the dots using another dashed line going across the graph like this. Okay, so those are asymptotes. Now let's go ahead and locate our y-intercept, 0, 4. And we have two x-intercepts, 4, 0, and -3, 0. It's right there. Okay, so now what we need to do is go ahead and draw the lines. Now remember, they're kind of hyperbolic, or they kind of have like this curve to it. And remember, they're always going to be on opposite sides, or like if these are vertical angles, so to speak, right? They're going to be opposite from that. So I'm going to draw this one starting close to the dotted line. And then, well, that wasn't very good. Apologize, we'll try one more time. Going through the points in a curved motion like that, but not crossing the dashed line. Okay, same thing with this one. Still didn't graph that one very well. I'm trying to go through the point. Okay, there. That's good enough. Okay, on to number 2. So the first thing I'm going to do is go ahead and I have to factor the numerator. So this is going to be x minus 4, x minus 1. Factor the denominator. The first thing I'm going to do to factor this one, though, is I notice that they all share a -3. I'm going to go ahead and take that out. Okay, so it's plus x minus 2. And then factor just this stuff over here. So altogether on the bottom, it's -3, x plus 2, x minus 1. All right. Now I'm going to ask myself, all right, now that I've got this all factored, is there anything I could cancel? Yes, the x minus 1s can go. And so what I'm going to do is, to answer the questions, okay, I'm going to use just this portion here. Oh, I don't like that color. Okay, just this portion, not the stuff that I canceled out. Okay, so the first question I need to answer is, what's the vertical asymptote? Okay, take the denominator, set that equal to 0. You get that x equals -2. All right, because you got -3 times x plus 2 equals 0. And when you solve, get x plus 2 equals 0, you get x equals -2. All right, next thing I need to know is, what is going on with, with my other asymptote? Do I have a horizontal or slant? Remember, for slant, okay, I'm going to look at these right over here. That means the top degree here has to be one more than the one on the bottom, and it's not. So that means I'm going to have a horizontal asymptote. Do you notice how they're exactly the same? They're both 2's. When they're both 2's, you can come up here and check out the rule real quick with me. Okay, if n is equal to m, and they do, they both equal 2, then we say that y equals a over b. Okay, a is this part right over here, right? It's the coefficient of the front here, okay? And b is the coefficient of the denominator down here. So, I don't know why this won't work. Okay. So this is a 1, and that's a -3. So it's a over b. So that means the horizontal asymptote, the way I write it, looks like this. It's going to be y equals a is 1 over b. So it's a -1/3. Okay, now let's do our y-intercept. Plug in 0 in for x. What do you get when you do that? I like to use the original equation for that. So turn all those x's into 0, 0, 0, 0, and 0. So you're left with 4 over 6, which is 2/3. So y-intercept is 0, 2/3. X-intercept, take the denominator and set that equal to 0, right? Okay, so I'm sorry. So the x-intercept, we're going to take the denominator, I'm sorry, the numerator on the top here and set that equal to 0. On the top part here, we've got x minus 4. So this is going to be 4, 0, right? So x minus 4 equals 0. So you get that x equals 4. That's why I've got 4 there, and then y was 0. Last thing is, are there any holes? Yes, because we ended up canceling out these x minus 1s. Well, whenever you do that, that means that x, the x part of the hole here is going to be a positive 1, right? Which is like the opposite of what you see here. This is x minus 1. So what does x need to be to make that 0? Is positive 1. But if x is 1, then what is y? So we need to find out the y portion of it. So come over here, we're going to plug 1 in for x. All the x's get 1s. All of them do. Okay? And so you have 1 squared minus 5 times 1 plus 4 on the top. On the bottom, you have 3 times 1 squared minus 3 times 1 plus 6. Plug all that into your calculator, and you get 1/3. All right, now it's time to go ahead and graph. So vertical asymptote at x equals -2. Horizontal asymptote, y equals a -1/3. It's going to be somewhere over here. Okay. Our intercepts, 0, 2/3, 4, 0. Okay, and the last one is our hole at y1. What is that? 1/1/3. I'm going to go 1/1/3 somewhere over here. Somewhere over there. Okay, so when I go to graph this, you guys, remember I need 2 of these curves. The top one will be easiest because I could go through, I'm going to go starting through there, go through that point, stop at the hole, do not cross it, right? It's a hole for a reason, right? So that the graph doesn't actually go through that point. So keep a nice big circle right there. And the other side doesn't have any points, and that's okay. We're just going to estimate. There, that looks about right. Okay, and then we're done with that one. Let's go to number 3. All right, let's start. I can't simplify that, so vertical asymptote is going to be x equals -3, right? Because it's x plus 3 on the bottom. Set that equal to 0, and that's what you get. On the top part, I've got n is 0. You don't see an x over there. So n is going to equal 0, and m down here is equal to 1, right? That is the degree down here at the bottom, but the top part doesn't have any. And the rule is that if it's heavier on the bottom, okay, let's come over here real quick. So this case, n was less than m, that's this part right here, then the horizontal asymptote is always going to be y equals 0. So horizontal asymptote is y equals 0. Okay, our y-intercept, we're going to go ahead and plug in 0 in for x. You get 3/3, which is 1. X-intercept. All right, we're going to take the numerator, which is 3, and set that equal to 0. But wait a minute, 3 doesn't equal 0. So that doesn't even make sense, which means that there is no x-intercept. When that happens, you just don't have an x-intercept. Okay, and there's no holes since we didn't actually cancel out anything or simplify it. So now it's just time to draw. X equals -3. Okay, y equals 0. Y-intercept is at 0, 1. And there is no x-intercept. So when I go to draw this, okay, the upper right-hand corner I know is going to be one of the curves, and I know that there's always one opposite to it, and even though there's no points there, I'm just going to guess and draw something that looks good to me. There, that looks about right. And that's it for number 3. Number 4. Can I simplify this? Let's see, it's 2, that's x plus 4 on the top, and an x on the bottom. So no, there's nothing that's going to get crossed out. Okay, so let's take a look at the vertical asymptote. We're going to take the denominator, which is x, set that equal to 0, so you just get x equals 0. All right, let's look and see what's going on here. This has a degree for horizontal asymptote. This is a 1, and on the bottom is a 1. Hey, that's equal again. And when those are equal, they're the same. Before it was 2/2, right? And this is 1/1. When that's the case, that means we're going to have a horizontal asymptote located at A over B. A is 2. and b is whatever is the coefficient of x on the bottom. So it's 2 over 1, which is just simply 2. So we're going to have y equals 2 for the horizontal asymptote. Okay, so y-intercept, plug in 0 in for all the x's and see what you get, right? 0 here, 0 here. Wait a minute, you get 8 over 0. Can you divide by 0? No, that's a problem. So that means there actually is no y-intercept for that. Okay, but there will be an x-intercept. We're going to take the numerator, okay, and we're going to set that equal to 0. So 2 times x plus 4 equals 0. Divide each side by 2. You get x plus 4 equals 0, so therefore x equals negative 4. So I'm going to have negative 4 comma 0. All right, so let's go ahead and graph now. So I've got x equals 0 is my vertical asymptote. That's right there on the y-axis. Okay, y equals positive 2. There's a cross right there at the 2. There is no y-intercept, but there is an x-intercept at negative 4, 0. That's right here. So when I go to graph now, okay, it's going to look like this, going through that point, a nice curve. And I know I'm going to have one on the opposite side that looks just like that. Okay. Alrighty, on the next side, it says that you've got 4 more that you're going to do. And it starts with number 1 again. So just make sure you're in the right place, and you can still use the same rules as the very front side. So let's start. Vertical asymptote, and we would kind of go from there. But let's begin by factoring. Okay, to factor the top portion here, that's going to give me x minus 4, x plus 3, because negative 4 times 3 is negative 12, and when I add them together, I get negative 1. On the bottom portion here, I'm going to take out negative 3 as my greatest common factor, which leaves me with x minus 3 in parentheses. Can I cancel anything? No, unfortunately not. So this is what it is. Vertical asymptote. In order to find that, you have to take the denominator and set that equal to 0. So let's take x minus 3, set that equal to 0. You get x equals positive 3. Now, do I have a horizontal asymptote or a slant? Let's take a look at this. N is 2, M is 1. So it's 1 more on the top than it is on the bottom, which means it's going to be a slant asymptote, not a horizontal this time. Okay, so slant asymptote, remember we got to do some synthetic division. Okay, I'm going to do synthetic division over here. I got positive 3 over here because that's what would make the denominator equal to 0. So positive 3. And then I wrote down the coefficients of the numerator up here on the top. And then now it's time to divide. Bring down the very first number, multiply, add, multiply. Well, it doesn't matter what's going on in the end over there because all we need are those first 2 portions here, right? So this is 1x plus 2, or in other words, it's going to be y equals x plus 2 to keep it simple. Okay. Next, y-intercept. Let's go ahead and plug in zeros for all those x's that are up here and see what we end up with. So it's going to be 0 squared minus 0 minus 12, negative 3 times 0 plus 9. So I'm going to go ahead and simplify that. That gives me negative 4 over 3. So it's negative 4 thirds. So plug in a 0, you get out a negative 4 thirds. All right, negative 1 1/3. X-intercept. Take the numerator and set that equal to 0. I like to use the factored part for this. So come over here now. I've got x minus 4, x plus 3, right? What would make the first part equal to 0 is if x were a positive 4. So I have positive 4, 0. And then over here, I've got x plus 3. So I'm going to have negative 3, comma 0 for my x-intercept. Go ahead and erase this. And there are no holes because I did not simplify anything, right? Nothing got canceled out. So let's begin. x equals 3. I know, could have been straighter. All right, at y equals x plus 2, so right here at positive 2, rise 1, run 1. Okay, connect the dots with another dashed line. And now go ahead and see what we could do about these points. Y-intercept is going to be located at 0, -4/3. 0, -4/3 is like a -1 1/3, maybe like right here. Okay, and then 2 x-intercepts, one at +4 and one at -3. Wait, something went wrong. Okay, so what ends up happening here is that the slant asymptote is a little more complicated than what we expected. So we got some good practice, and you get to omit this problem. So I'm going to get rid of that slant asymptote. These points are not going to make sense, and you get to omit the problem. The other things were right, though, vertical asymptote and such, but we're going to hit omit on number 1. Okay, let's go to number 2. First thing we're going to do here is factor. Okay, I went ahead and factored the top portion here. Now for the bottom, I have to take out a -3 for the greatest common factor. All right, so I took out a -3, and now I need to go ahead and factor what's there. So this is -3. Split up the x's, 2 numbers that multiply to give me -2, but add together to give me -1, or -2 and +1. All right, can anything cancel? That's a no. All right, so now what we're going to do is go ahead and start working through the problem. Vertical asymptote, back at it again. Take the denominator and set that equal to 0. Hey, check this out. There's 2 portions to the denominator this time, which means we're going to have 2 vertical asymptotes. Okay, so let's go back here. This was actually, when I took out the -3, I should have got a positive x over here in the middle. So that's going to change this to an x plus 2 and this to an x minus 1, which is great because now we see that x minus 1s will cancel out. And then to answer the question for vertical asymptote, remember y'all, you're going to only use, right, whatever you have left over to answer the question. So don't use the x minus 1 part of it to answer the question. Let's look at vertical asymptote. Take the denominator, set it equal to 0. I've got x plus 2 equals 0, therefore x equals -2. All right? Now I need to figure out what my horizontal asymptote is going to be. One of the things I noticed about it is that I do have a horizontal asymptote because that's a 2 and that's a 2. Remember that whenever n and m are exactly the same, you're going to end up with y equals a over b for your horizontal asymptote. A is up here, that would be 1, and b is the coefficient of the bottom, which is -3. So I do it with y equals -1/3. Okay, what's the next thing we need to do is start figuring out the intercept. So y-intercept. Okay, let's clean up some of this. We're going to plug in zeros in for our x's. Put a 0 in everywhere here for this one, and this one, and this one, and this one. That makes all of those go away, and I'm left with 4/6. Which simplifies into 2/3. So my y-intercept is 2/3, 0 to 2/3. Then for my x-intercept, I like to use the factored one for this one. Okay, you have to take the numerator here and set that equal to 0. So I have x minus 4 equals 0, which means that x will equal 4. So I get 4, 0 for this one over here. Okay, and then the last thing is to find the whole. So, did we cancel anything out? Yes. We canceled out, y'all remember, the x minus 1 part that's right over here and here. So if x minus 1 is the part that we ended up canceling out, that's gonna make our whole. So if I've got x minus 1, that means x is positive 1 is part of our whole. But I don't know if you remember how to find the y portion of that. you're going to plug in a 1 everywhere you see an x. So there's 1, and there's going to be a 1. So let's go ahead and figure out what that's going to equal. I'm going to make some room by erasing some of this. Okay, so what's 1 minus 4 on the top? I get -3. And then -3 times 1 plus 2 is -9. And -3 over -9 is positive 1/3. So it looks like my hole is located at 1/3. So the vertical asymptote, okay, let's start with that, was located at -2. So x equals -2 is right over here. Okay. The horizontal asymptote is located at y equals -1/3. That'll be down here somewhere. Okay, let's go ahead and plot our points. 0, 2/3, somewhere over there. X-intercept is 4, 0. And there's a hole located at 1, 1/3, somewhere right in there. Okay, so now it's time to draw. I'm going to draw a nice curve going through this point, but not going through the hole, at least trying not to. I'm sure you could do a better job with your pencil. Okay, and do the other side, just like that. Okay, all right, good job. Let's go ahead and go on down to number 3 and 4. Number 3, not a whole lot to do here, right? I mean, there's nothing to simplify or anything, so I'm just going to go get right to it. What is the vertical asymptote? I have to take the denominator, which is 4x, set that equal to 0, and you get that x equals 0. Horizontal asymptote. Well, the top portion here, this gets confusing. You don't see an x, right? So therefore, n is equal to 0. Well, down here, m is equal to 1. I don't know if y'all remember, but when the numerator, or n, is less than m, then the rule says that the horizontal asymptote is going to be y equals 0. Okay, then the next thing is the y-intercept. The y-intercept, you remember plugging zeros in for x's, you get 1 over 4 times 0, which is 0, and you can't have a 0 in the denominator. Therefore, there is no y-intercept. Okay, so there are also no x-intercepts here, right? Because when we take the numerator, which is 1, set that equal to 0, that is false. 1 does not equal 0. So there is also none there. And the last thing for holes, we didn't cancel anything out, so there's also none. So how are we going to graph this? This will be fun. Vertical asymptote is located at x equals 0. That's right there on the y-axis. So go ahead and draw your dotted line going down. Your horizontal asymptote is located at y equals 0. Okay, that's at the x-axis. And now I need to figure out where this graph is. We don't have any points to help us. So I'm going to pick a random number and plug it in and see if I can find the point. I'm going to take a random number. I'll pick the number 1 and plug it into the equation. So it's 1 over 4 times, I'm plugging in 1 for x. Okay, and what do I get out for y? I get out 1 over 4, which is 1/4. So that means that point must belong there. So that's 1 point. And so all I needed to do was figure out 1 point, and then I could sketch this graph. So I've got my asymptotes, and I've got a point that's right over there. So I know the graph must live right over here in this corner, which means the other one must be in the opposite corner. Okay, it was as simple as that. Okay, let's go to number 4, and this is the last one. Let's start by breaking this down, taking out the 2. Does that help anything? Are we able to cancel anything? No. So let's begin. Let's start with the vertical asymptote. Take the denominator, set that equal to 0, and you end up with x equals 0 for that one. Now we need to figure out if we've got a slant or horizontal asymptote. Look at those degrees on the top. That's 1 and the denominator is also 1. Remember, when they're exactly the same, that means you're going to have a horizontal asymptote at y equals a over b. What is a and what is b? A is the coefficient for the numerator here, which is 2 over, it's going on down here at the bottom, which is 1, and 2 over 1 is the same thing as saying 2. So horizontal asymptote is y equals 2. Next, we have our intercepts. The y-intercept. Plug in 0 into the equation and see what you get. So I got 0 here and a 0 here. Oh, we can't have a 0 in the denominator. Therefore, none. Okay? So for the x-intercept, we take the numerator and set that equal to 0. Okay, that's right up here on the top. Okay? Whenever we take the numerator and set that equal to 0, here, let me erase this. You get 2 times, right, x plus 4 equals 0. Divide it side by 2. Get x plus 4 equals 0. Therefore, x equals negative 4. So we do have an x-intercept, and it's located at negative 4, 0. And are there any holes? No. The reason why is because we didn't have to cancel anything, remember? So now it's time to graph. The vertical asymptote, going up and down at x equals 0, that's on the y-axis. The horizontal asymptote's at y equals 2. There is no y-intercept. X-intercept is located here at negative 4, 0. So now, at least we know now what side of the graph it's on, and there's nothing else. So now it's just time to sketch it. Okay, got a curve going through that point, and since it's over here on the bottom left, and I know on the top right, I'm going to have another one just like that. Okay, and if you have any questions, let's take a look at, it's right over here. We go full screen. Okay, go back, pause it, and take a look at the answers to see if you've gotten anything right or wrong. Okay.